Every day, more than 100,000 tons of glass are produced worldwide. In France alone, annual production reaches several 100,000 tons. And in Brazil, it is estimated at around 1.5 million tons. To meet this immense demand, thousands of tons of sand must be processed daily. This seemingly ordinary resource actually turns out to be the basis of a material essential to our daily lives. But have you ever wondered how this fine dust becomes one of the most widely used solid materials in the world? In this video, we'll take a closer look at how glass is made from melting silica sand. Stay with me until the end to discover this fascinating process, the result of thousands of years of expertise and innovation. The modern world simply could not exist without glass. This extraordinary engineering invention is present absolutely everywhere around us. It's found in buildings, cars, smartphones, eyeglasses, flat screens, and even the solar panels that power some of our renewable energy. At first glance, glass may seem fragile, but it's actually capable of amazing strength. When tempered or reinforced, it can withstand extreme temperatures, high pressures, and even violent impacts. Thanks to its strength and versatility, glass has become an essential material in construction, industry, and science. Its discovery is believed to date back to antiquity, when ancient people accidentally heated silica-rich sand with wood ash containing sodium carbonate. Upon cooling, this combination created a glassy material, the precursor to the glass we know today. Legends even tell of Phoenician traders lighting a fire on a beach and discovering, the next day, this translucent material that shone in the sun. The oldest glass objects date back to ancient Egypt and Mesopotamia around 3000 BC. These were small pieces like beads, amulets, or containers, often opaque and colored thanks to the addition of minerals. In Egypt, glass was used to imitate precious stones and adorn jewelry and religious objects. A few centuries later, around 50 BC, the Romans invented the technique of glass blowing, which revolutionized production. Using a simple hollow tube, they were able to quickly create amphorae, bottles, bowls, and glass pane. This discovery democratized the use of glass, which ceased to be a luxury reserved for the elite and spread throughout the empire. In the Middle Ages, glass experienced another boom with the appearance of stained glass windows in cathedrals. These immense colored compositions, made from metallic oxide, made it possible to depict biblical scenes while still letting in light. Later, in Venice, master glassmakers from the island of Murano perfected unique techniques, such as artificial rock crystal and filigree, resulting in pieces of unparalleled finesse. With the Industrial Revolution, new furnaces and modern machinery enabled large-scale production. Flat glass panes for windows and mirrors appeared. However, the process remained expensive and complicated. Glass plates were cast onto metal surfaces and then extensively polished and sanded to achieve a smooth surface. This made manufacturing slow, inefficient, and very expensive. A decisive turning point came in 1952 when British engineer Sir Alistair Pilkington invented the float glass method. This innovation consisted of floating molten glass on a bath of liquid tin, ensuring a perfectly flat and even surface. Thanks to this process, it finally became possible to produce transparent, smooth, and uniform panes continuously, in large quantities, and at a lower cost. Even today, more than 90% of flat glass is manufactured using this method. The basic raw materials used to make glass are silica sand, sodium carbonate, and limestone. Recycled pieces of glass, called calcanes, are often added to accelerate melting and reduce energy consumption while limiting environmental impact. This mixture of raw materials is called battle. Silica sand, which makes up about 60% of the composition, is extracted from quartz-rich deposits such as dunes, riverbeds, or sedimentary rocks. Once collected, it is washed, sieved, and freed from impurities to obtain a pure and homogeneous material. Large glass factories can receive up to 5,000 tons of silica sand per week. The raw materials are stored in huge silos, then carefully measured and mixed before entering the furnace. Each component plays a specific role. Sodium carbonate lowers the melting temperature, while limestone improves the strength of the glass. Recycled glass shards, which melt faster, optimize the furnace's efficiency. Other additives, such as iron, copper, or cobalt oxides, provide distinctive shades of green, blue, brown, or even black. Once prepared, the batalie is introduced into the melting furnace. This monumental furnace, built of refractory bricks, operates continuously 24 hours a day, sometimes for 10 to 15 years without being turned off. The temperature here reaches between 1500 and 1600 degrees Celsius, usually thanks to natural gas. The raw materials liquefy, releasing gases and forming a homogeneous mass. The viscosity of the molten glass is constantly monitored to ensure optimal quality. The molten glass then passes into a hotter zone to remove bubbles and impurities, ensuring perfect composition and homogeneity. At around 1100 degrees Celsius, it flows gently onto a bath of molten tin in a protected atmosphere of nitrogen and hydrogen to prevent oxidation. The difference in density makes the glass float on the tin like oil on water. Thanks to gravity and surface tension, the mass spreads into a continuous, perfectly flat sheet of uniform thickness. The final thickness depends on the speed at which the glass is fed and the roller setting on the edges. When it leaves the bath, the glass is solid but still very hot. It then enters a long, annealing furnace called an LER, where it is gradually cooled. This controlled cooling process prevents the glass from cracking or breaking too easily. Once stabilized at room temperature, it is transported on conveyors to be cut by automatic machines. These, equipped with industrial diamond tips, mark the surface and allow a clean break along the cutting line. The plates can be cut to standard or custom dimensions. The entire process is supervised from a control room that monitors in real time the temperature of the furnaces, the quality of the glass, the speed of the production line, and the precision of the cutting. Sheets with defects are immediately removed, crushed, and reintroduced into the chain as recycled glass. Validated sheets are stacked vertically on sturdy metal racks, separated by protective covers to prevent scratches and bumps, then packaged and shipped to market. In the case of artisanal production, the steps are carried out in a much more manual manner. Each furnace contains molten glass of different colors to create various plates. Craftsmen use special cones to extract the liquid glass, which they must work quickly to prevent it from solidifying too early. Multiple colors can be mixed to create unique effects. Before stretching the mass, the glassmaker mixes it with a tool resembling a large fork, then passes it between rollers that press and flatten. The distance between the rollers determines final thickness. The resulting sheet is then annealed and cooled gradually to avoid any brittleness, then cut manually using tools with diamond or tungsten carbide tips. But glass isn't just for windows or bottles. In science, it's used to make optical fibers that carry light and enable high-speed internet. In astronomy, it makes up the giant mirrors of telescopes. In medicine, it is present in syringes, pharmaceutical ampoules, and even some bioactive implants. Glass is also used for security, such as bulletproof glass, or in recent innovations, such as foldable screens. As a result, more than 100,000 tons of glass are produced every day worldwide. This material, born from the encounter between sand, fire, and human ingenuity, has accompanied the evolution of our societies for over 5,000 years. But don't leave yet. That's not all. The rest of this video will be just as fascinating, so stay tuned until the end. And most importantly, don't forget to like, subscribe, and hit the bell so you don't miss any of our upcoming content. Also, leave a comment to tell us where you're watching from and what you thought of this content. There's a plant that grows so fast that it seems to defy the laws of nature. It doesn't need to be replanted after each harvest. It adapts to extreme climates and can be transformed into a house, a utensil, paper, and even food. Its name, bamboo. While a tree can take between 30 and 100 years to reach maturity, some bamboo species achieve this in just 3 to 5 years. This rapid growth rate makes bamboo one of the most renewable natural resources on the planet. Additionally, its ability to regenerate without the need for replanting makes it even more efficient and sustainable. But that's not all. Bamboo is also a natural carbon dioxide absorbing machine. It is estimated that it can capture up to 35% more CO2 than traditional trees. What would happen if we replaced plastic and wood with bamboo in our everyday products? What if, instead of clearing hectares of forest to make paper, we used this miraculous plant? Every year, millions of tons of bamboo are harvested around the world. From Asia to Latin America, its cultivation has become a driving force for sustainable development. Flexible, strong, and above all incredibly versatile, bamboo has thousands of applications in homes, construction, and industry. Its impact is hard to overstate. Today, we'll take you on a journey to discover how this ancient plant has revolutionized entire industries. From its harvest in rugged terrain to its transformation into the object we use every day, what you're about to discover isn't just a production line. It's a veritable green revolution in progress. Prepare to dive into the amazing cycle of bamboo. We promise that by the end of this journey, you'll never look at this plant the same way again. Growing bamboo may seem simple, but its large-scale production requires thousands of years of expertise and perfectly coordinated logistics. In many parts of the world, bamboo plantations are located on mountain slopes, where access is difficult and the use of heavy machinery is nearly impossible. This is where human ingenuity comes into play. Farmers in these areas use traditional techniques, often passed down through generations. Armed with sharp machetes, they carefully select ripe stalks, distinguishing those ready to be harvested from those that have yet to grow. This selective practice is essential. It ensures that the mother plant continues to regenerate, thus avoiding overexploitation. Once cut, the bamboo is not left to rot. It is tied into bundles, transported on foot or on the backs of pack animals along steep paths to accessible areas where it can be loaded onto trucks. In some places, improvised pulley systems are even used to lower the bundles down slopes. This process may seem rudimentary, but it is perfectly adapted to the environment. In addition to its efficiency, bamboo cultivation has a positive environmental impact. Unlike intensive monocultures, these plantations can coexist with other plant species, protect soils from erosion, and improve air quality. Thanks to its dense, deep roots, bamboo is ideal for stabilizing land vulnerable to landslides. Unlike other commercial crops that require a lot of water and pesticides, bamboo is remarkably resilient. It can thrive in poor soils and variable climates, making it a viable option even in regions affected by climate change. And because it doesn't need to be replanted after each harvest, maintenance efforts are significantly reduced. This balance of tradition, efficiency, and sustainability has enabled thousands of rural communities to find a stable and environmentally friendly source of income in bamboo. But this plant's journey has only just begun. What follows is its transformation, a fascinating process where a simple stem becomes a useful, sustainable, and eco-friendly object. Once the bamboo is harvested and transported to the processing plants, an astonishing transformation begins, combining artisanal precision, hygiene standards, and technologies adapted to sustainable development. Each stem is evaluated according to its thickness, length, and density. Only the best are selected for food or high-performance products. The rest are destined for the manufacture of paper, textile fibers, or compost. One of the most common uses is the manufacture of disposable chopsticks. Every day, millions of units are produced in factories operating with extreme efficiency. First, the bamboo is cut into small sticks of uniform length. Then, a machine polishes the ends, removes imperfections, and rounds each piece with millimeter precision. Although it may seem simple, behind it lies a complex industrial logistics process aimed at maintaining consistent standards of hygiene, speed, and quality. After molding, the baguettes undergo a critical disinfection step. They are briefly immersed in an antifungal and antibacterial solution, then dried in special high-temperature ovens. This process not only prevents the growth of bacteria, but also significantly extends the product's shelf life. Finally, they are individually packaged in biodegradable packaging or vacuum-packed in pairs, ready for global export. But the usefulness of bamboo goes far beyond that. The same raw material is used to make spoons, forks, spatulas, reusable straws, and even toothbrushes. To shape these objects, steel molds are used that apply pressure and heat to create ergonomic designs. Vegetable oils are then applied to waterproof the surface and protect it from wear. No harsh chemicals or synthetic varnishes are used, ensuring a natural and safe product. These eco-friendly alternatives are growing exponentially. Around the world, cafes, restaurants, and supermarkets are already replacing plastic with bamboo utensils. A plastic straw takes 400 years to degrade, while a bamboo straw only takes a few weeks. Additionally, its natural appearance and unique grain give it added perceived value among environmentally conscious consumers. This versatility also stimulates creativity. Some workshops design complete sustainable cutlery sets, including spoons, forks, knives, and straws, accompanied by a recycled fabric case. These products are a hit with students, travelers, and urban workers looking to reduce their daily ecological footprint. In addition, small family businesses have developed exclusive ranges of personalized utensils, using laser engraving techniques and natural pigments. This not only increases the aesthetic value of the objects, but also encourages local trade and the preservation of cultural identities. In Indonesia, India, and Colombia, this cottage industry has generated thousands of jobs in communities previously dependent on less sustainable activities. Bamboo products are not just an eco-fashion trend. They embody a new way of thinking about consumption, responsible, conscious, and in harmony with nature. They prove that it's possible to combine beauty, utility, and respect for the environment in a single object. And to think that it all begins with a simple stem silently growing at the top of a mountain. In the next part, we'll see how this same bamboo can even challenge industries like paper and construction, demonstrating that its potential is only just beginning. Bamboo's journey doesn't end with the kitchen. This ancient plant also has the power to transform the way we build and write. In the paper and construction industries, bamboo has established itself as one of the most versatile, durable, and environmentally friendly materials of our time. To produce paper, bamboo undergoes a specific process. Unlike trees, whose fibers are often thicker and more difficult to process, bamboo has a long, flexible, and very strong cellulose. These fibers are extracted by grinding the stem into a viscous pulp. This pulp is then washed, bleached without chlorine, and dried to produce soft, strong, and biodegradable sheets of paper. It is used for notebooks, napkins, packaging, and even toilet paper. In addition to its quality, it has a major advantage. While a tree takes several decades to regrow, bamboo can fully regenerate in just 3 years. This reduces pressure on natural forests and significantly reduces the ecological footprint of conventional paper. But its potential in construction is even more impressive. Its hollow, fibrous structure gives it tensile strength comparable to that of steel. In Asia and America, it has been used for centuries as the primary material for roofs, scaffolding, and walls. Today, modern architects are rediscovering it as an environmentally friendly alternative to concrete and brick. A single hectare of bamboo can provide enough material to build a 100 square meter house, while an equivalent project would require deforesting between 10 and 12 hectares of traditional forest. This difference not only means a lower environmental impact, but also lower costs and much shorter construction times. Compressed bamboo panels are already revolutionizing interior design. They're used for floors, walls, furniture, and even ceilings. They are durable, water-resistant, and aesthetically pleasing thanks to their natural grain. Additionally, they offer thermal and acoustic properties that improve home comfort. And bamboo isn't just functional, it's beautiful too. Its warm, organic appearance provides a connection with nature that no other material can truly emulate. In a world where construction is one of the most polluting industries, bamboo emerges as a tangible, renewable, and visually striking solution. It's a plant that breaks paradigms. Lightweight yet robust, fast yet durable, simple yet sophisticated. Its use in paper and construction illustrates how nature can offer us solutions to our most pressing problems if we learn to listen and collaborate with it rather than fight it. But beyond its industrial uses, bamboo possesses extraordinary ecological power. Its cultivation is not only efficient, it is also regenerative. In a world threatened by the climate crisis, this plant stands out as a natural ally for restoring environmental balance. One of its most notable benefits is its ability to absorb carbon dioxide. Studies have shown that it can capture up to 35% more CO2 than conventional trees. Planting bamboo is therefore about more than just avoiding emissions. This actively helps remove them from the atmosphere. In addition, it releases large amounts of oxygen, making it a natural air purifier. Its impact on soils is equally valuable. Its deep, extensive roots stabilize sloping land, prevent erosion, and improve soil structure. This is crucial in degraded areas or those subject to prolonged periods of drought. Bamboo can grow on poor soils, revitalizing them without the use of chemical fertilizers or pesticides. Because it doesn't require replanting after each harvest, it reduces soil depletion and limits human intervention. Its continuous growth cycle makes it a nearly self-sustaining plant, ideal for low-impact agriculture. This also reduces costs and facilitates its adoption by rural communities with few resources. Globally, the bamboo market is booming. Demand is growing in diverse sectors such as construction, fashion, biodegradable products, and even food. This economic growth translates into more jobs, greater energy independence, and a reduced dependence on polluting materials. Furthermore, bamboo fits perfectly with the principles of the circular economy. The residue from its processing can be reused as biomass, compost, or even transformed into biofuel. Nothing is wasted. Every part of the plant has a purpose, reinforcing its role as a comprehensive and efficient resource. Faced with climate challenges, bamboo is not a single solution, but it constitutes a powerful tool within a broader strategy. Its sustainable cultivation, combined with responsible environmental policies, can help us build a greener, fairer, and more resilient future. And the best part is, we're not talking about a distant promise, but a reality that's already underway. To conclude this journey, let's see how each of us can make a difference. Throughout this story, we've seen how a plant as simple as bamboo is capable of transforming entire industries, from chopstick making to sustainable housing. It's not just a raw material. It's a natural solution to many of the challenges our society faces. Bamboo embodies a new way of thinking about progress. Rather than endlessly exploiting resources, he teaches us to regenerate them. Rather than pollute, to purify. And rather than exhaust, to preserve. It is, without a doubt, a symbol of green hope. Now that you know its potential, the next time you hold a straw, a notebook, or a pair of bamboo chopsticks in your hands, remember that beyond this object lies an entire ecosystem functioning in harmony. And don't forget that there are also human choices that make a difference. Bamboo is already changing the world. Do you want to be part of this change too? If you enjoy discovering how nature can guide us towards a more responsible future, leave a like on this video, subscribe to the channel, and activate the bell so you don't miss our next documentaries.